Hello students, I hope you all are fine. So students, today also we will discuss about one more free radical, one more intermediate, that is the free radical. Okay, so what do you mean by the free radical? First, we should know free radical means in which carbon has carbon. Here we cannot say only carbon, not we can say carbon. If any species, if any chemical species have odd number of the electrons, odd number of electrons, then it is known as the free radical. Like students, if I talk about chlorine, I am having chlorine, okay, and students, restart करो. रिफ्लेक्शन तो नहीं आ रहा स्टूडेंट की वजह से. रीस्टार्ट करना दोबारा बताना, इरेज करना. Hello students, I hope you all are fine. So today we will discuss about one more intermediate, that is the free radical. Students, free radical is a chemical species. Here students, we can take any atom or group of atom. We can take an atom or group of atoms. If any atom or group of atom have odd number of electrons, or we can say has unpaired electrons. Odd number mean unpaired electrons, like 1, 3, in this way, then that is known as the free radical. Like students, if I have chlorine, Cl2, and students, when I pass, so I can write chlorine in this way. You know very well, in chlorine there are 7 electrons, there are 7 valence electrons. 287 is the configuration. In this one also there are 7 electrons. For completing their octet, they form covalent bond. They do mutual sharing. Both are sharing 1 electron. And after sharing 1 electron, it is having 7 plus 1, 8 electron. It is also having 8 electron. But students, when sunlight symbol of sunlight we can write in this way, H nu. When sunlight fall on this one, then what will happen? Homolytic cleavage take place. Homolytic cleavage, or we can say homolytic fission will take place. homolytic fission will take place, students. What will happen? When sunlight will fall on this one, then here the electron which is shared by this one, accepted by this one also. This bond will break and homolytic fission will take place here. One electron taken by this and one electron by this one. Means equally distribution of electron will be there. Equally distribution of electron will be there. Then what will happen? This Cl having already 6, this one electron further it has taken. Simply I can write in this way, because these are in pair. This one is unpaired electron. This one is the unpaired electron here. Okay. So here two species of chlorine free radical can form. One from this side and one from this side. Clear or not? So student, here homolytic cleavage means when equally distribution of the electron takes place after dissociation, after cleavage of the covalent bond, Here this one is the covalent bond between these two chlorines, because it is formed by mutual sharing of electrons. One electron shared by this one and one electron shared by this one. Then they form a bond for completing their octet. So that bond is known as the covalent bond. That bond is known as the covalent bond. Sunlight we will fall on it, then what will happen? Because both have same electronegativity. So one element will not accept both of the electrons. It has also same electronegativity. So what will happen? This bond will break from between, and further one electron will be taken by this one and one by this one. Clear? So this is known as the homolytic cleavage. And after homolytic cleavage, the species which is formed okay, we can do again. I think cleared it is. So homolytic fission we will show by this sign. Clear? And if heterolytic fission take place, then we will show by this one. Clear or not? So when sunlight fall on this one, then formation of free radical take place. And if equal distribution of electron take place, then it is known as the homolytic fission. It is clear to you or not? Yes. Then students, classification. We classified carbocation, carbanion in primary, secondary and tertiary. In same way, we can classify free radical also in primary, secondary, tertiary. Okay. If students, the carbon, here it is having one odd number of electron, it is having, because we are talking about free radical. So 3 bonds, it is forming with hydrogen. Then it is methyl free radical. It is known as the methyl free radical. And if it is forming one bond with other carbon, then it is known as the primary. ethyl free radical. It is primary or ethyl. This is the CH3 CH2 free radical. Clear? If carbon is forming other two bonds with carbon, then it is secondary or isopropyl. Isopropyl. And if it is forming all three bonds with other carbons, then students, it is known as the tertiary. It is known as the tertiary. So free radical can also be classified into 0 degree, 1 degree, 2 degree and 3 degree. Okay. Students, if we talk about stability, here stability order will be same as that of the carbocation. What was the stability order in carbocation? 3 to 1. Then methyl. So here also this will be the stability order. This will be the stability order. This will be the stability order. Okay. Why it will be? It is having one electron. Okay. It is also electron deficient species here. Carbon. You can see carbon is having 2, 4, 6, 7. Only 7 electron. Its octet is not completed. Its octet is not completed. Okay. So if number of alkyl groups are electron donating groups, electron releasing groups, donating groups. So it needs some more electrons and they can help it. Clear or not? So if alkyl groups increase, then stability increases. And other factor was hyperconjugation. Hyperconjugation means what was the important points of the hyperconjugation? In hyperconjugation, there should be alpha carbon. If this carbon having free electron, odd number of electron, so adjacent carbon is known as the alpha carbon. Okay. And the hydrogens attached with this one are known as the alpha hydrogens. It need electron. So from where it can take? Who can help it? Either this hydrogen, either this one hydrogen can help. Okay. If it will help, then no bond resonance take place here. So one resonating structure we can form. Clear or not? In this way. So students, you can see 9 alpha hydrogens are here. 9. This one also alpha, this one also, these 3 also, and these 3 also. So if number of hyperconjugated structure will increases, then stability also increases. So in this way you can show the stability on behalf of hyperconjugation also. Okay. If here 9 alpha hydrogens, so it can form 9 structures. Here how many? 6 alpha hydrogen only, so it can form 6. And here 3. And here no one. So if number of hyperconjugated structure increases, then also stability increases. Clear or not? In same way. And if reactivity order, then is asked, then what will be reactivity order? Just reverse, just reverse. In reactivity order for 0 degree means for methyl free radical. For methyl free radical maximum, then 1 degree, 2 degree and for 3 degree minimum. Now students, orbital structure. Orbital structure. This one is methyl free radical. How can you calculate hybridization? Number of bonded atoms plus number of lone pairs. So students, here you know very well this carbon is forming one bond with this, one this and one free electron here. Then you can see how many bonded atoms? 3. 1, 2, 3. 3 bonded atoms plus how many lone pairs? No. Lone pair not here. Lone pair means one pair of non-bonded electron form one lone pair. But here only one electron present, beta, not in pair they are present. Clear or not? So pair not here. So lone pair is 0. Lone pair is 0. So 3 plus 0 is equal to 3. And if this value is 3, then what will be the hybridization? 2. sp2. Clear? So student, here also this carbon will be sp2 hybridized. And if it is sp2 hybridized, then structure will be, the geometry will be the trigonal planar. Trigonal planar. Trigonal planar. Okay, and this angle will be 120 degree. 120 degree. Clear or not? Any doubt in this? Yes. So students, we have discussed about 3 intermediate first one was carbocation, carboanion and free radical. These are the important points for them you will keep in your mind. Here carbon has positive charge. Carbon has positive charge. Okay, carbon has positive charge. Carbon has 6 valence electrons. 6 valence electron. Carbon sp2 hybridized. Planar structure. Angle will be 120 degree. And stability order. Stability and reactivity. Stability order will be 3 degree, 2 degree, 1 degree and then methyl carbocation. Okay, and reactivity will be reverse here. So it will be methyl 1 degree, 2 degree and 3 degree. Clear? Then in carbanion, carbon has negative charge. Carbon has negative charge. Carbon has 8 valence electron. Carbon has 8 valence electron. Carbon is sp3 hybridized. sp3 hybridized. Shape will be pyramidal. Shape will be pyramidal. Angle will be less than 109 degree 28 minutes. And stability order Stability order will be reverse, just opposite to the carbocation. Primary, secondary and tertiary. Okay, and reactivity order just opposite. 3 degree, 2 degree, 1 degree, methyl. Clear or not? Yes. Then free radical. Carbon has odd number of electron. Odd number of electron. Because organic chemistry we are studying, that's why I am saying carbon here. Okay, and here carbocation, already name we are discussing. Here free radical may be other also. Any other atom which have unpaired electron, which have odd number of electrons on it. That is known as the free radical. Clear? Here we are talking about carbon only because we are discussing about the organic chemistry, and in organic chemistry we study hydrocarbons. Clear or not? That's why. So odd number of electron, and how many electron will be there? 7. 7. Then sp2 structure planar, angle 120, and then stability same H, carbocation, tertiary, secondary, primary and methyl, and reactivity opposite. These are the main points for these intermediates you will learn. We will apply again and again. You know, when we will, our next topic will be the type of the chemical reactions. And in chemical reactions, when we will do in next unit also, I will say this will be the major product, but this will be the minor product. So that majority and minority we will give on basis of the stability of their intermediate, on basis of stability of their intermediate. Okay, maybe information of one product primary free radical there, and in second formation secondary is taking place. Okay, so I will prefer the secondary because it is more stable. So the compound which is formed by the secondary free radical, where intermediate is secondary free radical, that will be more stable as compared to primary. So you should know about their stability and reactivity orders. Clear or not? So you will apply mainly these orders, stability and reactivity order, mainly you will apply in reactions. Okay, tomorrow we will start to discuss about the type of the reaction. Students, here we will discuss about 8 type of the reactions. Types of reactions. Like we will discuss about addition reaction, addition reaction, substitution reaction. Here students, not only one reaction we will discuss. In inorganic chemistry, you were discussing in 10th class displacement reaction, when one element replace other. That is known as displacement reaction. Substitution is also same thing. Substitution also same thing. But here we will discuss nucleophilic substitution reaction, where one nucleophile will substitute other. Electrophilic substitution reaction, free radical substitution reaction. In this way we will discuss nucleophilic addition reaction, electrophilic addition reactions. Okay, in this way. Then elimination reactions. Elimination. In some reactions, elimination of water take place, elimination of carbon dioxide, ammonia take place. Means if any molecule is separated out, then it is known as the elimination reaction also. Rearrangement reaction. You know students, sometime we do rearrangement of element also. during a chemical reaction. Like if in a chemical reaction, primary carbocation is forming, but one possibility there, by shifting one or more element, we can form it, we can convert it into the secondary. So we will do that for giving stability to that. So rearrangement we can also done. With example we will do all these things. Then pericyclic reaction also, isomerization, polymerization, polymerization reaction also there. One more reaction also, like condensation reactions. There are 8 type of the reactions. Students, if you know about mechanism of, you will not learn only reactions. If you know about mechanism of all these 8 type of reactions, then organic chemistry is very easy. Then organic chemistry is very easy, because in whole organic chemistry we will say here nucleophilic substitution take place, here electrophilic substitution take place, here this one. So if you know about mechanism of these, then organic chemistry will be very easy for you. So tomorrow we will discuss one by one all these reactions. Okay, so thank you, have a nice day.